Well, welcome everyone. This is our third briefing session for the review of SDPi 1.0. It's also the first day of winter, so welcome aboard on this first winter day. This is, as I said, our third session, and so our session so far has been a general overview, which kind of helped you understand what is the organization of this SDPi 1.0 specification, what's unique, what's different, what's challenging. There's a profiles overview. We have 4 profiles. So as a supplement, it's not just one profile for the supplement, it's actually 4. And so we talked about that in session number 2. Today, our focus is on gateways. We have 2 specific gateways that are included in version 1.0 of this SDPi specification. One for a DEC, device to enterprise communication, and one for ACM, alert communication management. So we'll look at those in detail today. And then we also have a final 4th session, a general Q&A scheduled for January 11th. All of these sessions are recorded and are posted now on this library page in Confluence. So hopefully, if you miss anything from the previous ones, you're able to go back to this one and catch up. So on the 14th of December, last week, this is our overview, our general overview that we did. We gave you this SDPi's profiles, the big picture. We talked about how we went around developing this, the outline for the supplement that, we're starting with the IHE PCD 2019 technical framework, but then we have the 2020 technical framework template that we're mapping it into, and that's how we got to this supplement in 2022. So there's an organizational challenge, and then we talked about the 4 volumes of the technical framework, TF framework, and all the general, the kind of the key issues with that. So that was our first one. We have a bunch of links to where you can go find stuff. It's all online, easily accessible. We talked about this organization for the 4 profiles. Now, SDPi includes for plug and trust, SDPi-P connectivity, and then one each for reporting, alerting, and external control. We have these broken out because depending on the system implementation, it might implement SDPi-P and R and A, but not external control, or maybe SDPi-P and R, but not A and not external control. So we partitioned it in this way to have this foundational establishing plug and trust connectivity, and then these more focused areas. These are also directly aligned with the SDC participant key purpose standards, IEEE 11073, 1070, 0, 1, 2, and 3, those 4 standards that are in development and publication, which are aligned with this as well. And so this allows us to have a medical interoperability purpose with a shared risk management mitigation standard for each one of these. And we also have these gateways, which is what we're talking about today. And specifically, we are anticipating having a fire gateway, not in 1.0 though, but we do have DEC and ACM gateways to those profiles, which are based on HL7 version 2 messaging. We also have a general version 2 messaging gateway actor. Okay, so these are all the actors that we're going to look into today, and across these 3 volumes for profiles, transactions, and biceps content. So we looked at that today. And then we looked last time at the profiles. I won't spend a lot of time in there, but one of the things we did talk about last session, and we will again today, is this idea of grouped actors, an actor that inherits capabilities from more foundational actors in other profiles. So we'll look at that specifically today. So here we go. Let's dive into the gateways overview. Today, what we're going to really focus on is giving you an overview of how the gateway actors work within SDPi profiles in general. And then we will, Peter Chronic, who is the author of these gateway specifications, will give us a detailed tour for the DEC and ACM gateway specifications. So with that, I will first cover these top 2 questions, which has to do with connector actors, bidirectional APIs, and baseline and specialized gateway actors. And to do that, what I'm going to do is look at a current rendering of the IHE SDPi technical framework 1.0. Now we're finishing this up. We're actually about hours away from the version that we will send out for you to review. There's still a few things in here that are needing to be finalized and polished for this 1.0. But as we showed you last time, we have in SDPi this actor model, okay? And this actor model looks at SOM's participants. SOM's participant, which is a stereotype, it's a foundational abstract actor, is basic to all systems that want to network across an SDC network. We have provider systems and consumer systems. And those provider and consumer systems also may interact with systems that are not SDPi enabled. So that's represented by these non-SOM systems. SOMs, by the way, means service-oriented medical device systems. So it's the architecture, the service-oriented architecture that we use for SDPi and for the IEEE SDC service-oriented device connectivity standards. So what we're focusing on today are these here, and notice that these all are provide you a way of interacting with these external systems. So they're connectors in that sense. The connector is also abstract. It basically defines a standard way, a standard API here for how these gateway actors can interact with SOM's providers and consumers on this side of the network. And then, of course, the gateway provides connection to other systems outside here. And those systems, in one case, may interact directly with all of these, and sometimes they're specialized. So notice this line actually goes very closely into here to these applications, software as a medical device type applications that are external. So we've identified in SDPi 4 gateway or connector actors, and one is for fire. HL7 Fire 1.0 won't have that. But we anticipate having this actor added in 2.0 in 2023. We have a sensor gateway for integrating sensors that don't have network capability, but they provide signals or maybe actuators that you can change that have an API that would be accessible over here. So we will be adding that in a subsequent version. And of course, then this smart app platform, which we've identified, but it's not part of 1.0. Today, what we're focused on is this gateway actor for HL7 version 2 messaging, okay? And this here, within this part here, represents a generic use of HL7 version 2 messaging. What you'll find is that within IHE devices, the profiles for enterprise integration today leverage HL7 version 2 messaging, but a specific kind of message, an ORU R01 message, and a specific way of utilizing the fields within that message for device informatics. And so that general approach for how you profile that, those are requirements and specifications are part of this gateway actor. But then, as you know, we have 4 profiles. So the other one, the next one, is this SDPi reporting here. And this, you can see, has this DEC gateway actor, SOM's DEC gateway, but it inherits from that V2. So the general, how do you use an HL7 V2 ORU message for mapping into the SDC world? That's contained here in that logic, but now what we do is for the DEC, we get very specific. Now we're mapping to Dev01 or PCD01 messages that are provided to a device observation consumer. So in that sense, the DEC gateway acts as a reporter, device observation reporter. That detailed content here is what you'll see in Appendix B of Volume 2 that Peter is going to cover in a minute. Now, for version 1.0, we're really looking at only this line here. So being able to receive information that is provided by a SOMS provider system, and be able to then translate that, map that into PCD01 or Dev01 transactions out to other systems like an EHR out here. And so that's how this will work. In future versions, we might be able to receive these messages from other device gateways, for example, into this DEC gateway and be able to provide that into these systems here. We might be able to have an SDPi SOMS medical device consumer that is able to receive this information in a Dev36 from a gateway. Again, though, that gateway will do that translation from SDC biceps semantics to the HL7 version 2 ORU R01 semantics. So that's what we're going to look at. This is kind of the high level. And then also we have an ACM gateway that Peter will be going into, and it's the same thing. So alert communication management, it again leverages that base general HL7 version 2 gateway actor from SDPi, but then adds the logic that's necessary to be able to interact with systems that are Dev ACM enabled. Specifically for 1.0, we're only supporting the device 04, the reporting of alert information. And that would be then from one of these systems here that would provide a Dev39. So you can see Dev39 is publish medical alert update. Well, that interaction could also be provided here to this gateway, which would then translate that into Dev04 messages that would go out then, for example, to an alert manager or an alert consumer system out here. So that kind of gives you the overview of what we're looking at here for this SOMS ACM gateway and SOMS DEC gateway. But there's a lot of detail under the hood. And so what I'm going to do now is stop presenting and turn it over to Peter, and he's going to give you kind of that tour of Appendix B in Volume 2, the gateways, and then give you a pretty good tour of these two gateway specifications so that when you review it, you're able to look at the details and make sure that they're all in place. So with that, I'm going to stop sharing, and Peter, you should be able to share your screen and take us on the tour.
Okay, so how do I do that?
You click on start. There should be a green share button at the bottom of your.
Okay, I see that. Yeah. Thank you.
And here it is.
Can you see my screen?
Yep.
Okay.
Looks great.
So hello everybody. So I will talk about Appendix B, the gateways, and I will start with the general mapping of the HL7 version 2 gateway. So in this chapter, this is pretty small at the moment. So all the common stuff is fully integrated also in the DEC gateway and the ACM gateway, but we probably will move this out. For example, some general stuff like the patient information, the patient identification, segment mapping, and so on. But for now, everything is fully described in the DEC gateway and as well in the ACM gateway. One question to the reviewer, one issue we have that is that SDC only supports the UTC time, and the question is if we should send the UTC time without a time zone through the from the gateway via an L7 to the system, or if the gateway has to do something to add a time zone or local time to the timestamps. This is one question to the reviewers here. Then I will proceed with the next section, which is the DEC gateway. We only support here the vital signs and data reporting. This will not cover the wave data reporting, only numeric data, enumerations and string data will be reported here. In this section B32, reference standards and profiles, you can see the standards we refer to in this mapping. So very important is here that the IHE PCD technical framework version 2, volume 2, and also here the SCC standards, which is the core standards, as well as the participant key purpose standards, the base participant key purpose, as well as the metric participant key purpose standard here. In the next section, we have a description what to consider about the MDC codes. So as you know, the MDC has a standardized code, but it has also a range in each partition where you can define your own private codes. And when in SDC, you have to add, this is also part of the SDC standard, you have to add a translation element. And when this translation element is present for a certain code, then you have an alternative mapping as well. And this describes that you have to generate your own ref ID if it's not already there, adding the private code, and as an additional alternative coding system, you can add the information from the translate element here. This shows also a couple of examples how this could look like here. So the next section is that the detailed description of the segment mappings. We refer to the Appendix B in the technical framework, volume 2. All the segment fields which are not described in here will the original mapping described in the technical framework will apply. So when here only the MSH segment is mapped here, the MSH 11. When nothing else is described, all the other fields are mapped according to the technical framework. So this field here, the processing ID, has to be mapped to the state of the device or to the operating mode. If the device is in a production mode, so in a normal operating mode, or if it is in a demo mode, service or maintenance mode. So this is then also mapped here in this field. The next segment we are mapping is the patient identification segment. Here we have to, the gateway has to check some prerequisites if you have a valid patient context. This is also described in the base participant key purpose standard that each context has to be associated with a beginning of the association with a binding time, and then an inferred context has to be derived from the patient context, and only then you can use this patient context information, and this is described in this requirement here. The rest of the mapping is pretty much straightforward. So you have this patient identifier list. So also SDC provides identifier lists with certain codes for which kind of identifier this is. So it could be an account number, for example, visit number, patient record number. Then SDC also provides the patient name, family name, the first name, and so on. Mother's maiden name mapping. So this is really straightforward. Day of birth. There was also a big discussion about the administrative sex. So we will have in the future also an extension for the gender and for the biological sex. And the discussion is here when the device in the past we only had one field for the administrative sex in the P2 segment, and the question is what the devices have used in the past. So if this is always the administrative sex, or is it more the biological sex, because we are in a clinical environment and the biological sex is more relevant to any algorithms in the medical device. And the discussion is if we should stay here, not map this segment or this field at all, or if we should always use the biological sex. So this is also a question for the reviewers here. Then the next field is the race mapping, the identity unknown identifier. And the core data also contain height and weight, which is not a field in the PIT segment of HL7. So in this case, we will map this as a separate OBX segment with the height and the weight. So this is describes here the mapping. The next segment we will map is the patient visit segment. In the patient visit segment, it's the same. So we can have a location context that has to be associated, and the binding start time has to be set. And from the context, an ensemble context has to be inferred to indicate that this is a valid location index that the gateway can use and export via HL7. This is the mapping about the patient class, the associated assigned patient location here. This is straightforward. So HL7 SDC has a dedicated field with the location details with all this information. Then there's the field with the visit number. So the visit number is also from the patient context, should be mapped in here. The admin datetime can be derived from the binding start time of the patient context, and this defines here how the visit indicator is mapped to this field. The next segment we will map is the observation request segment. So the first, the OBR2, is the identifier of the gateway itself. So the gateway is always a DOR, a device observation reporter. This is also set in the OBR3. It's the same information for the DEC profile. Then we have the universal ID. This is a little bit tricky, so there's still some discussions how we will map this then. So what is required for infusion pumps and so on. This is still on for this special devices still under discussion. In the OBR7 segment, we will set the observation time. This is defined in here. And this depends a little bit what kind of data you have. So if you have continuous data, either a numeric metric, for example, then the determination time could be set in the OBR7 segment field. And when you have an intermediate or episodic metric data, then in the OBX14 field will have an individual timestamp for this metric value instead. Observation end time. So this is the same. This should not be used here in the SDC context. Then when you have also a user context, this can be set here in the OBR10 collector identifier field to give some information about the operator of the device. And then we have the next segment we will map is the OBX segment. So the OBX2, which is the value type, depends now what kind of metric you have. If you have a numeric metric state, a string metric state, or an enumeration string metric state, and according depending on this different states, you map this to either a numeric string or coded the value. The next is the device related segments. So at the MDS level, the VMD level, and as well on the channel level, you will have one OBX segment that identifies where the metric in the tree is located. So this is also exported here. And the information are available in SDC on the channel level, VMD level, and so on. On the metric level, we have also a code, and usually the default is that this is an MDC code, and it could be also a private code, as I have shown before. You have to consider then how to map the private code. The OBX4 is the observation sub-ID, which is a flattened representation of the SDC element in the hierarchical containment tree. So this is shown next here in an example. So the gateway has to take the various handles, so from an MDS level or from VMD level, and then have to map internally these handles, which are unique in the MDIP structure, to a unique number here. And this shows here an example on the MDS level. Here you have then this kind of numbers, and on the metric level you have this number here with the identification for the VMD and channel as a number. Then we map here from the metric, numeric matrix, string metric, or an enumeration string. And this is defined all in here. Especially when you have an enumeration, it's a little bit more complicated in SDC, because you have the string value, and you have then to look up, and there's this shown here. You have then to look up in the allowed values which code does this value have in the for the coding for the coded term in the value field. In the case of a numeric metric, you can have units. You have the units mapped here. Then the reference ranges are used for the alarm limits. If a certain parameter has alarm limits, or technical ranges can be set here. This is the limit alarms, so it should have the alarm limits. Abnormal flag mappings here. The OBX11 is the observation result status, which is usually an X for all the device-related parameters, or an R when it's validated, when it's a valid metric. And when it's validated, it should be F in this case. The OBX14, as I mentioned before, is an individual timestamp for this value, and it's only used for episodic values usually. At the OBX16, you can also set the operator, if available, who operates the device and creates the value. In the OBX17, the observation method. So it can be mapped here. This was an automatic measurement or a manual entry, or it's a calibrated value, and so on. Okay, then this is how to identify. This was also a question, how to identify here an individual device. The SDC provides an UDI here, a UDI field, but UDI is not always available. and it's not clear right now how we would identify a device. Maybe we can combine values from the production specification, like the type of the device and the product ID plus the serial number, but this has to be figured out. So we are happy about every comments on how this is done in a specific product. Then OBX20 is the mapping to the body sites. And that's already for the deck profile. For the ACM profile, for the ACM mapping, it's basically the same. So the first part is basically the same. So we also have here the private code mapping. We have the MSH segment, we have the PIT segment, and the TV1 segment. So I will skip this. This is totally identical. Going further down. Yeah. So it starts here with the OBR segment. This is a little bit different for the ACM profile. So the OBR2 is the same. So we also have here the alarm reporter identifier here. So this is the gateway itself, so the alarm reporter of the gateway. And the OBR3 segment, there should be then the unique identifier for the event, for the alarm event. And it depends now if this is the initial alarm event announcement message, then this is filled with the alarm event identifier. And in any subsequent alarm event messages, this is then an identifier for this message, and the initial alarm event identifier will be moved to the OBR29 segment. So this shows how to map this then. The OBR4 is fixed set to a certain code here. This is defined in the ACM profile as well. The OBR7 is the timestamp when the message is sent, not the timestamp of the event. And as already mentioned in the OBR29, the parent field, this is then filled with the unique event identifier. And on the OBX side, we have, for the alarms, we have 7 OBX segments. This is for the event identification, the source identification, event phase, alert state, inactivation state, alert priority, and the alarm type. Also here we have the segments for the MDS, VMD, and channel. This is identical with the deck profile as well. Also here we have this equipment identifier with this open question, how to identify a quick equipment uniquely. I'll skip this one. Observation identifier, yeah. For the channel and for the, so for the event identifier OBX segment, this identifies the alarm event, and this is different between a technical alarm and the technical alarm and an advisory or a physiological alarm. So in table 28, there's more information about it, how to map this. So the alarm type is mapped here for the generic one, and then here we have this special mappings depending on the physiological, technical, and others. Yeah. Going back here. So the event phase mapping here. So we have different phases. So we have the start phase, the continue phase, end phase, update, escalation, de-escalation, and reset in the case of an alleged alarm. And this describes here which fields in the SDC biceps model you have to use to determine the individual alert phase states. This one, this is an example here how this alert event look like. This is the event identification mapping. This also depends if this is a physiological alarm, then it could look like this here. And for the technical alarms, it looks a little bit different. Then you have here this as an example for a technical alarm. The source identification observation identifies the source. So for physiological alarm, it's basically the parameter who caused the alarm event, which is then also exported as an OBX segment in here. So it's referred to the DEC profile because the rendering of the alarm source is exactly the same. So it's a numeric parameter, for example, when this is a limit alarm. For physiological alarm, yeah, this is an example for a physiological alarm. And for technical alarms, it's a little bit different. And it's described in here. And here you see an example of the alarm source. So this is the alarm attribute source, and then the device or the metric who caused the technical alarm, for example. Then we have the event phase OBX segment mapping, which is described in here. There are different alarm event phases: start, continue, end, update, escalation. That's what you already said. Then we had the alarm state observation, alarm state OBX, which is described here. So the state could be active, inactive, or latched. And also this gives information about how to determine in which state you are currently in. Then the next segment is the inactivation state OBX segment. It's described here. The different activation states are enabled, audio paused, audio off, alarm paused, alarms off, and alarm acknowledged. And also here, this is the mapping of the SDC elements and how to determine the different inactivation states. Priority. So in every alarm condition descriptor has a priority. This priority can then be mapped to DEC ACM profile priority. The priority can change in SDC. So when you have an escalation or de-escalation, the alert condition state actual priority should be used in this case, because this has the actual number or the actual priority which should be mapped. And this shows here the mapping from the SDC value to the HL7 value used for the priority. And finally, we have the alert type, which is in SDC the alert condition descriptor kind attribute. And these are the different kinds here: physiological alarm, technical alarm, or other, which could be an advisory. And here's the HL7 value mapping defined for this attribute. The participation information segment will not be mapped in this SDC context. That's all from my side.
Fantastic. Peter, a lot of work. There's a
Yep.
lot of detail under that hood.
Thank
But
you.
it is very, let me go back to where we were. Here we go. But as we said, you know, there's this clearly shows the intersection between the SDPi, the SDC network world that generates alarms, that generates data that gets reported in DEC and ACM, and how that maps in. There's some things that are very clear and straight, and there's some open issues, and some things that work well on one side, but not necessarily on the other. You've done a fantastic job at capturing both the mappings as well as some of those open issues. So good, fantastic. As I said, this is as part of reviewing, so preparation to be able to give a review by the IHE devices group as a whole, domain as a whole. And for those areas of the specification that are probably the ones that we really would welcome focused attention on, it would be these two gateway specs, because our hope is to be able to go to a Connectathon in 2023 and be able to not only do plug and trust interoperability between SOMS systems in an SDPi world, but also to interact with these gateway actors and be able to generate PCD01, PCD04 messages that would then be able to work with the rest of the IHE devices profiles, some of the key ones there. So give these two specs a very close attention. We appreciate it. The other part is, Peter, you did an excellent job at integrating and showing the use of requirements blocks. So as we said, for this SDPi specification, we've gotten much more formal about how we identify requirements. So it's pretty obvious as you went through and showed. This 1.0 version that aspect is still a work in progress. We will hopefully have quite a bit more added before we transition to the public comment version late January. However, I would welcome those, to provide feedback in a general sense in terms of how we use those requirements blocks. All right, so that is the end of our session number 3. And hopefully between the general overview, the profiles overview, focused SDPi gateways overview, provide the comments that we need to update this, get it all finished off and ready for public comment publication the end of January. We have one more session, 11th of January. That's a Wednesday, just like now. 20,023. Maybe we should update that on the slide deck. And it'll be again at the same time in January. And with that, I would welcome you. And by the way, if you want to be added to that calendar invite, let myself or Sarah or one of the Ken Fuchs or John Rhodes know, and we'll get you added into that. And it's a general Q&A. So if there's topics we haven't covered or didn't make a bit of sense, or if you've looked at the 1.0 version, it's like, yeah, there's something that just doesn't make sense, come to that time and we'll make sure we address those. And with that, thank you, everyone. Happy holidays today. Now that we started winter, now that we're getting really close to January 1st, I hope everybody has a healthy, safe, and enjoyable time this holiday. So thank you very much.